Kinematics is an essential field, unlocking the secrets of motion without delving into its causes. Imagine the world around us. Every moving object tells a story of motion waiting to be uncovered. At its core, kinematics focuses on distance, displacement, speed, and velocity, fundamental concepts for understanding motion. Objects are studied in relation to an observer, who measures changes in physical quantities like speed and direction. When a boy watches a bird fly, he becomes an observer, highlighting the relative nature of motion and rest. The position vector illustrates an object's location concerning the observer, bridging the gap between perception and reality. Whether a point object or a sprawling mass, the parameters of rest and motion change based on perspective. Rest occurs when the object's position is constant, while motion signifies a shift in position over time. Imagine different observers. An object might be resting for one yet be in motion for another. Understanding mechanics entails studying parameters like speed, acceleration, and the forces producing these motions. Kinematics differs from dynamics, focusing solely on motion's description, leaving causation to the dynamics realm. Distance represents the actual length of the path traveled, a scalar quantity unbound by direction. Conversely, displacement provides the shortest straight-line distance between an object's initial and final positions, offering deeper insight. Think about walking 3 kilometers east and then 4 north. You've traveled a total distance, but what's your displacement? Kinematics invites us to explore speed and velocity. Speed, the scalar measure, while velocity incorporates direction. Average speed signifies the total distance over time, differing from instantaneous speed, which pinpoints motion at any moment. Velocity represents the rate of change of displacement, creating a vivid tapestry of an object's motion dynamics. Sudden changes in direction illustrate acceleration's presence, which can be uniform or variable, affecting motion's essence. When a particle accelerates uniformly, its path can take a linear or parabolic form, broadening the realm of possibilities. Equations of motion emerge, guiding our understanding of how velocity changes with acceleration, crafting a pathway for inquiry. Projectile motion exemplifies two-dimensional motion, propelled into the air by forces we often take for granted. As we analyze trajectories, we realize horizontal motion remains constant while vertical direction is influenced solely by gravity. Imagine tossing a ball. Understanding its path from launch to landing requires knowledge of both horizontal and vertical components. The beauty of projectile motion invites us to explore parameters like time of flight, maximum height, and horizontal range. Ever wondered how angles impact distance covered? 2 different angles can yield the same range, challenging intuitive thinking. In kinematics, analyzing rain or river motion showcases how motion parameters shift based on the observer's frame of reference. The relative motion of objects teaches us to analyze movement through different lenses, from stationary references to moving observers. As we navigate the concept of relative velocity, we unravel complex interactions between moving objects and their environments. With practice problems at our fingertips, real-life scenarios beckon us to employ kinematic equations in meaningful contexts. From simple motion to intricate projectile paths, mastering kinematics equips us with tools to unravel the chaotic dance of the universe. As we conclude, remember that every moving object carries a story. Kinematics is the key to interpreting that narrative. Embrace the world of motion. Each concept mastered builds a bridge to understanding the universe's wonders. Discover the secrets of kinematics, the fascinating study of motion without force interference. Kinematics allows us to comprehend how objects move through space and time, revealing nature's hidden patterns. What exactly is kinematics? It's the exploration of motion devoid of the forces that cause it to change. Let's break down some essential terms to unlock our understanding: the object and the observer. An object is the entity under observation, while the observer notes its movement. This could be a bird or a boy. Understanding the position vector is crucial. It indicates the location of an object from an observer's perspective. Now, consider the concept of a point object. These are objects so small that dimensions are negligible in our calculations. Rest and motion are key ideas in kinematics. Their definitions rely on the observer's perspective over time. If an object's position remains constant to an observer, it is at rest, otherwise, it's in motion. Dive into mechanics, the larger framework encompassing kinematics, which focuses solely on the parameters of motion. Mechanics branches into statics, dynamics, and kinetics, each pivotal for revealing the dynamics of rest and motion. Distance represents the total path traveled by an object and presents itself as a scalar quantity. In contrast, displacement is the shortest distance from start to finish, a vector that includes direction. Distance cannot be negative, while displacement can, showcasing its unique properties as a vector quantity. The relationship between distance and displacement is fascinating. Displacement is always less than or equal to the distance. For example, walking 3 kilometers east and 4 kilometers north results in a distance of 7 kilometers but only a 5 kilometers displacement. Speed offers another layer, measuring how quickly distance changes over time, always delivered in positive terms. Velocity, however, adds direction to speed, representing a more comprehensive understanding of motion in kinematics. Uniform acceleration denotes a scenario where acceleration remains constant. This is crucial for understanding object movement. Equations governing displacement under constant acceleration unleash the potential to solve intricate motion problems. The nuanced differences between uniform and non-uniform acceleration can dramatically impact our motion analysis. Graphs play a pivotal role in depicting motion, with distance time and velocity time graphs highlighting key relationships. The area beneath a speed time graph represents the total distance traveled, solidifying the connection between these concepts. Embarking on a journey with projectile motion unveils more complexities regarding how objects behave under gravity. In projectile motion, a quaint dance unfolds. Horizontal motion remains steady, while vertical motion tastes gravity's pull. Air resistance may be neglected, yet gravity becomes the devoted companion, guiding projectiles in a parabolic arc. Time, maximum height, and horizontal range become our companions when analyzing the fascinating world of projectile motion. Understanding relative velocity opens doors to practical applications, enhancing our grasp of how observers perceive motion. From swimming across a river to navigating through rain, relative motion shapes our experiences and interpretations. Grasping acceleration, whether uniform or variable, transforms our understanding of how objects respond to forces. Mastering these kinematic concepts equips you with the tools to tackle physics problems with confidence and clarity. Kinematics isn't just numbers and equations, it's the rhythm of the universe, revealing how the world moves.